Hi class, this is Dr. Karsten, and today we are going to be working on angles. Specifically, we're going to be focusing on right, acute, and obtuse angles. So we've already talked about right angles, and that right angles are 90 degrees, and that they look like this. So this is the angle right there. And I remember speaking with you before about that we call them right angles, and the way I like to think about them is that they are the right angle for building things. So, for example, if I were building, these are right angles. So on a square or a rectangle, squares and rectangles have right angles. All four corners are going to be right angles. And if I were building with some squares, I could make a nice stable building. It would be really good and strong and stable. So for example, if I had a nice right angle, here we go, let me draw it here. So if I had bricks and they're nice right angles, and I went ahead and I put something on top of it, it would sit on there really nicely. However, if I had something with an angle like this, where the angles were not right, and I tried to put something on top of it, it would just slide right off. So if I put this on top of here, I tried to build on here, it's just going to slide right off. It's not going to stay nicely. So it's not stable. So right angles are the right angle for building because they're nice and stable. And in fact, when you see bricks, they're nice right angles, right? Like this, and then you'd have another brick on top. And those are nice and stable, and they're not perfect because I'm drawing them by hand, but they're nice and stable. Things won't fall apart. You see right angles all over in buildings. Your windows have right angles. Your doors have right angles. Where your wall meets your ceiling or your floor, it's a right angle. The corners of most rooms are right angles. So a majority, most, of the angles that you're going to see when you're building something are right angles because they're the right angle for building because they're stable. All right, so what about acute angles? Have you ever heard someone when they see like a kitten or a puppy or any baby anything and they're like, oh, it's so cute. It's a cute thing. It's so cute. Well, acute angles are cute too because they are tiny. They are less than 90. So an acute angle is less than 90. The alligator's going to need the 90 because it's bigger. The acute angle is less than 90. So an acute angle might look like this. And you see how I'm putting this little curve in there? That's to show you that I'm looking at this side of it. Let's make this one rays. The other one was line segments. This one's going to be rays. And so that's an acute angle because it's less than 90. If I took my 90-degree angle and I put it here, you can see it's much bigger. And in fact, you can see that angle underneath there. So this is 90, but underneath there you can see that it's less than 90. Okay, so we have right and acute. Now we're on to obtuse. And I like to say it like this. Obtuse. I sound like a big foghorn from a ship, a giant ship. It's big because obtuse angles are big. Obtuse. They're bigger than 90 degrees. An obtuse angle is greater or bigger than 90 degrees. They're huge. They're the big angles. And so this would be an obtuse angle. And again, I decided to use rays on this one. And so the angle's on the inside here also. And again, watch what happens when I go ahead and I put this 90-degree angle. I line up my vertex. What do you see? You can see that it's way bigger. This would be 90 right here. And this is way bigger than 90. So obtuse angles are greater than 90. They're big. They're obtuse. So right angles are the right angle for building. They're equal to 90. Acute, oh, they're so cute. It's an acute angle. They're less than 90. They're tiny. And then obtuse is greater than 90. Those are the big angles. So let's take a look at some angles. And let's see if we can figure out what they are. All right, so let's start with this one right here. No pun intended. So we're looking again on the inside here, and it didn't give me that little square marker. Remember, a lot of times when you have a right angle, it's going to give you the square inside to show you it's a square or a right angle. So let's take a look, and let's go ahead and let's just take this corner and let's see if we can line it up. So I'm going to line up with the vertex. Remember, the vertex is where two rays, two line segments meet. And I'm going to line it up on the bottom here, and you can see it lines up perfectly with both of these sides. So yep, that's a right angle. What about this one? Whoa, that's a ginormous, that's a huge angle. That angle is almost like two 90s put together. It's almost a straight angle or a straight line. Look, it is close to that. It is almost like having two of these together. If you had two of these together, if you had a straight line, that is a straight angle or 180 degrees. 90 and 90, 180. This one's just a little bit less than that. It's almost a straight line. It's slightly bent. So that's an obtuse angle. What about this one over here? Get this one in our view. What about this one? That's a teeny weeny little angle. Look at that. It's so tiny. It's so cute. It's a cute angle. It's a cute. And what about this one right here? Now this one I think is the challenge. When I look at this one, I consider this the challenge angle. To me, it looks a little bigger than 90, but I would definitely have to check it out. So I'm going to use something that I know is 90. I'm lining it up at the vertex where the two meet. And I'm going to line it up on the bottom line. So you can see that I have it lined up on the vertex, on the bottom line. And look what you see. It is bigger than 90. Look, I'm going to shade in this part. This is all the stuff that's between 90 and where the actual ray is. And look at that, it's definitely greater. So angle WXY or angle YXW, you can name it either way, is obtuse. It's obtuse, it's bigger than 90. Obtuse. Angle TUV or VUT is less than 90. It's a cute little angle. An angle NOP or PON, you could do it either way. That one's equal to 90. And this one was obtuse also. All right, so what about if I wanted to measure angles? What if I wanted to actually measure these and figure out exactly what they are? We use a tool called a protractor. And here, oh, you know what? I wanted to show you, well, we're good. I wanted to show you some protractor pictures. Now, normally you would get one of these and it's going to be plastic, and you would go ahead and you take it and you would line it up on the lines and then you could measure them. But since we're doing this virtually, we're going to be using it on paper and we're going to have these samples here. I went over the angles, I just highlighted them really quickly so that you'd be able to see them better. So when you take your protractor, and the first thing you have to do is you have to make sure most protractors are going to start up above the bottom. So you can't see how it didn't line up on the bottom? It lined up here where 0 is. So you would have to figure out where your zeros are. And that's where you're going to line up your vertexes and line the zeros. Now, a lot of them will have a little hole here. And what I like to do is I'll put a dot on my vertex just to help me find it. But a lot of them are clear, but they might have a dot right here. They're going to have two lines, but you have to find where 0 is. Where's your 0 line? Where is 0 degrees? Remember that we talked about this the other day. We measure with degrees. So you find it, and here, let me see. I think you guys can see that right there. You can see there's a 0. 0, 10, 20, 30, 40 right there. And on the outside, though, it's 170, 160. Down here would be 180, just to let you know. And on the other side, and here I've colored over it, so we're going to look right here. Right here is 10. Right here would be 0. So right here would be 0 on the outside. And what you can see is that there's a set of numbers on the outside and there's a set of numbers on the inside. And what you want to do is you want to be very careful and notice which numbers are you measuring with. And we're going to look at that a little bit more in a second. But just take a look. We have 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. Straight up is 90. 100, 110, 120, 130, 140, 150, 160, 170, 180. Straight line is 180. But then we have these markings on the outside. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160, 170, and here would be 180 right here. When you are measuring, you have to look, am I lining up with my inside numbers or my outside numbers? So let's take a look at this one right here. And they did such a good job lining this up for us. And I wonder if I'm going to pause and see if I can get us closer. All right, so I got us closer. A little tricky. But now what you can do is you can definitely see much better how we have the numbers on. Here's the outside measurements, 10, 20, 30. And then we have these inside measurements, so 0, 10, 20, 30, 40. So if I look here, my vertex is lined up right here in the middle where it should be. My bottom line, or ray, my bottom ray is lined up with the 0. Here's where 0 is, 0, 10, 20. So it's lined up with my 0, and often you'll have actually a 0 right here. So what I know is that since my 0 is on the outside numbers, here it's 0, 10, 20. On this side, it goes 0, 10, 20 on the inside. Since this bottom line is lined up with the outside 0, I'm going to look at my outside numbers to figure out how big this angle is. And what I want to do is I want to see, where does this line cross? And if I look carefully, it's right here. This is the number 60 is where it's crossing. 10, 20, 30, 40, 50, 60. So this degree measure, this angle here, is 60 degrees, and I could write that right here. It's 60 degrees. Let's look at the next one. So for this one, I'm lined up in the vertex. The vertex is right here where it's supposed to be. See, for this one, it has a little arrow. I'm lined up with the 0 line with this one, so this ray is lined up with the zeros. Here's a 0 right here, and it's lined up with this 0, so I'm going to use my inside numbers. So since I'm lined up, since this bottom ray is lined up with the 0 that's on the inside numbers, we're going to look at the inside numbers. We'll go round until we get to here. And you can see it's the same, it's lined up with the 60, but that's not what we're using. We're using the inside numbers. So it goes 100, 110, 120. So this would be 120 degrees. And these are nice because they're giving us really nice, easy to look at degree measures. Now, let's do another one that's easy. We'll do, I guess, 2 more easy ones, and then we'll look at a slightly trickier one. So here's the next one. So, lined up here, I'm looking over here, and I'm lined up with the 0 that's on the outside. So this 0 is on the outside. So we're going to use our outside numbers. Now this is an obtuse angle. This one was acute up there. The 60 was acute. This one's way obtuse. I can see that. So let's go ahead and let's take a look. So 10, 20, 30, I can go right around the outside, and I get to 160, 170. So this is at 170 degrees. I'm going to write that. It's 170 degrees. So let's look at the next one. So this one is again lined up on the left side here. So it's lined up with the outside numbers. And we have 10, 20, 30, 40. So this is an acute angle. It's less than 90. It's 40 degrees. So now, though, we're going to get a little different. We're going to have a different kind of an angle where it's not bending with its head. Let's look at this one. So it's lined up on the right side here. So it's lined up, the 0 is on the inside numbers. So let's look at these inside numbers. And we're going to go from 10 to 20 to 30 to 40 to 50. Wait, 50, 60. Do you see how it's halfway between 50 and 60? What number's halfway between 50 and 60? I hope what you're saying is 55. So this one's 55 degrees. So now we know this is 55 degrees. Let's look at the next one. And we have the same sort of thing where it's landing between. Now let's see first, are we using the outside or inside numbers? What do you think, outside or inside? Well, we're lined up right here. And this lines up with the 0 that's on the outside. This 0 goes with the inside. 0, 10, 0, 10. We're looking at the outside numbers. And if we follow along the outside, we get to 100. It's between 100 and 110. And you can see here, for the outside, you can see that they've actually put in the 10 little degrees in between, and even mark off where the 5s are. Here's 90, 91, 92, 93, 94, 95 is the slightly longer one. 96, 97, 98, 99, 100. The same thing's happening here. 100, 101, 102, 103, 104, 105, and it's right on that 105. So this is going to be 105 degrees. And again, that's obtuse because it's bigger than 90. 90 would be right here. Now, what's really cool is that I prefer using the outside because I feel like there's more details. So what I could always do is if I had an angle, I could choose which one of these to line up. And if I lined up the left one on this protractor, the left one is always going to be the outside number. So if I line up with the left 0, I get to use my outside numbers because I could take my protractor and I could switch it around and line it up with whichever one I want. All right, my friends. So we learned a bunch of really cool things. We talked again, it's going to be a little big now, I apologize. We talked about right angles and that they're the right angle for building because things will not slip off of them, right? If we have, this is not a right angle, if you try to build on that, it's just going to slide right off. But if you build with right angles, it's nice and stable. We also learned about a cute little angle, it's less than 90, it's so cute. And we learned about obtuse, which is greater than 90. We were able to estimate angles, take a look at them and make a guess, or we could use something that we know is a square to help us understand the angles. And if you do decide to ever do that, I recommend that you put a little color on the edges so that you can really compare them better. It'll make it a lot easier. So we were able to identify just by looking at things or using a square, a piece, something that we knew was 90 degrees. And then we were able to use images of protractors to help us measure. And remember that you have to always figure out, are you using the inside numbers or the outside numbers? And what you want to do is you want to figure out, is the 0, is it lined up with the 0 on the inside numbers or the 0 on the outside numbers? For this one, the inside numbers. For this one, it's the outside numbers. All right, my friends. And we also practice naming angles. I also want to remind you of that. We practice naming angles and that you'll always say the vertex in the middle. So like this would be angle NOP or angle PON. All right, my friends. I will see you in our Google Classroom. Bye.